Okay. So I'll just go to our first. Does anyone in the audience have a question?
Hi. So, Mike, I don't know if you remember, 4 years ago when we did the first formal verification conference in a different site, we talked about the C word and said, what are the thoughts on coverage and completeness formal. I would like to go back to the question and say, what should a formal verification engineer do for coverage and completeness? And are we anywhere close to being synergistic amongst the EDA spectrum, from the tool spectrum? And can we all do the same thing and talk the same language? Because, from Imagination's point of view, we supply IP, so we sell it to the customers, and they want to understand the same thing as we do. Not same word does not mean the same thing in different tools. So.
Okay. I was a bit worried when you said the C word, but I think I know what you mean now. So, coverage and completeness, and also consistency in the language as well. It's 3 Cs.
Okay, so hello.
Yeah.
So I think I referred to this question in my talk about the verification completeness. And I think we're definitely in a better place today than we were 4 years ago. Is formal in the same place as simulation? Not yet, but we are heading there, and we will be able to tell you how far you are along your verification task. Are you done with your verification task? I don't think we will be able to tell you the likelihood of remaining bugs in your design, as I pointed out. But in terms of, I think every vendor is going and solving the coverage problem, as we've heard from multiple talks today. And the next step probably will be to standardize it. But I think we're definitely in a much better place than we were 4 years ago.
Yeah. Feel free to.
So yeah, I agree. I mean, standardization is the way to go. I mean, it's there's interoperability between the different tools is very important. Yeah. And about the definition of the words. I mean, we, as I mentioned before, the completeness is is something that OneSpace has been offering for a while, and there's been a lot of our customers actually using that to verify their particularly critical designs already. I mean, for a long time. So I do think it's something that's in the future.
Yeah. So, can you hear me?
Yeah.
Okay. Yeah. So I think a feasible way to combine simulation with formal is the bug hunting approach, for example. That's one way how to combine these two techniques. So also I see a successful combination in using formal to rule out spurious coverage holes in simulation. So that maybe you're talking about that code, that is not covered by simulation. Generally, I find personally the question very interesting. How to justify proofs in general. So how to convince the user that the proof is valid or not. So I think we are going into this direction, and we have a first approach for that, but can get extended.
Oh yeah. So yeah, actually I agree all these statements. So regarding standards, so there is still some work to do regarding, for example, one thing is code coverage. And if we look to different vendors, they have different approaches. So if you want to mix tools, or you want to go from one tool to another one, it's actually not straightforward today. This is something that has to be handled at the standardization.
So there's some questions online which follow on quite nicely from your answers. All vendors talk about formal and functional coverage verification databases abiding by the Accelera standard compliance. I think they probably refer to UCIS. But how close are we? I think all of you mentioned that you want these the coverage metrics to be standardized, but UCIS is taking quite a long time. So does anyone want to comment on UCIS?
Yeah, so there is here work to do. This is actually, let's say, this is something that is, there is some work done in standardization, how to say, making things regarding coverage database standard, but we are still not there because there is how to export, how to say, results from one database to another database is still not how to say, supported as expected if we go from customer to customer. Nevertheless, so bottom line, actually, we have to be in sync about what are the coverage items that should be addressed in consistent way through the different vendors. And then when we are talking about this in different contexts of solutions and simulation or formal verification, then we are talking about the same stuff. This is not happening today. And this is where we have to put more energy on it.
Anyone else want to comment on? No. Okay. As it's progress, one voice speaking for all vendors on UCIS.
So what are you saying isn't happening today? That you're not speaking together, you're not agreeing what we need you to do? Is that the problem?
I don't think there is a problem. I think it is taking time, and I think the formal metrics, coverage metrics for formal are new compared to coverage metrics for simulation. We are working to adopt a standard. We want to enable you to sign off a design using formal only, and we understand that you require metrics to do it. We are working to get there. I think, as I mentioned, 4 years we've made significant progress. I agree there's still a road to go, and we are working on it actively. That's what I can say.
You are working together, so there actually is some
we are
way
working
of discussing this.
We are working to align with simulation, which is already aligned, and
that's within Cadence, right?
Yes.
I mean, we need you all to be talking to each other.
As I mentioned, we understand that, and it will happen. But I don't think that.
But you've been saying that for the last, whatever, 3-4 years, right? And I don't believe you had any conversations at all.
There has been some conversations, yes.
There is a standards body, Accelera, and I think there are conversations going on via Accelera, but they're very slow.
Yeah, I mean, it's taking time, but there is actually movement now. I mean, like, as I mentioned before, there is, from OneSpin's, this is OneSpin talking here, yeah. From OneSpin's point of view, there is now a partnership with Mentor and Synopsys, at least, to move this thing forward, and maybe eventually, others will join. But it's not speeding, but it's going in the right direction, and there is movement, right?
Is this for structural coverage or semantic coverage? Is it for making sure that the tech code needs the same thing and line coverage needs the same thing, or is it because everybody's got to do mutation or everybody's got to do observation coverage? Where are you in terms of your alignment with different vendors? Are these discussions on all aspects of coverage and completeness, or is it only about the structural side, which is the easy bit, really? You can all agree on what line coverage means, and then we could all say the same thing.
Well, I think it's about more than that, but you've got to start somewhere, right? I mean,
no, that's fine. Yeah, that's fine. But where are you? What exactly are you discussing? Would you mind sharing, or is it confidential?
I don't know.
Okay.
I mean, I'm not sure if I can.
Okay,
Yeah.
That's fine.
Well.
So basically, you're saying the three of you are on the same side, and you just have to persuade.
Well, I didn't want to say it quite like that, but it's like there is a, I mean, they're not the bad guys either. I mean, we partner with them on something else. Yeah. So it's there is a monopoly situation isn't good for anyone, and interoperability is important. People realize that, and it's just things take time.
Are any of your users part of this discussion?
Yeah, absolutely. They're the ones driving it.
there's some more users in the audience who want to join that.
Yes, following on this coverage thing, is there any work being done on coverage to requirements, bidirectional traceability?
I might join the panel at this stage. Great.
Yeah.
So Cadence provides a tool called vManager, and vManager includes test planning, where you can write your requirements, and then we correlate the coverage from all the different engines, emulation, simulation, and formal, back to your requirements. We show you how you covered your requirements, and that should answer your question.
So we have the same capability actually at Metro. We have common UCDB, common database where we are storing coverage from different tools, from formal emulation and simulation, and we have what we call test planning on verification management that talk all together. So within Mentor, we understand how to collect things together and how to put them to have, let's say, one plan or one kind of coverage result from all this or this solution together. And there is also another tool which is like Traces, use it to trace requirements from a specification into code and back into results together.
Yeah, so at Synopsys we have the verification continuum platform where everything is integrated. You have Verdi to uniformly debug your properties, to trace your counter examples. And yes, we also have a uniform coverage representation.
And at OneSpin we don't have a tool for that, so we're happy to work with anyone else.
And I can't resist the temptation, because TVS has a tool as well.
Yes.
So we can take requirements from DAWs, and then we can trace it to Cadence, Mentor, and OneSpin Design. In terms of what sort of quality? Top. I think I have to move on rather than do a commercial for TVS. So I'm going to move on to Chris.
So we've heard a lot today about finding bugs, and really the ones we've been talking about today are functional bugs. But if I have a graphics core that renders a perfect frame but can only do 1 per second, it's useless. If I have a CPU that can only process 10 instructions a second, it's useless. Have you used your formal tools in the performance verification arena? Because it's extremely difficult to do in simulation, and you can't really do it there either. So have you tried that? Have you got any customers that have tried that?
Okay.
I'm sorry. I'm on the spot here. I don't know. I think for functional verification, as far as I'm concerned, I can't think of a case where we've done something to measure performance. What you mean it's like depth of? Isn't that something that STA does or something like this?
No, this is, can your system process the data fast enough? It's not megahertz.
Okay, sorry, I misunderstood your question. Can you say again?
So if my processing engine can't process data fast enough,
yes,
then I can only get 1 frame a second out of my graphics core.
yes.
So that's a performance issue. It's not a megahertz issue. It's not a functional issue, but it still doesn't work in the system because I can only see 1 frame a second. So I can't process data fast enough.
Can you capture the performance as an assertion? Then you can prove it, right?
Maybe implicitly via design constraints, right? They have timing constraints that influence the actual speed under which you can
So maybe I'm talking
right?
this at 10 gigahertz. It still can't process the data fast enough.
I mean, for formal verification, even when you do not want to formulate these properties directly that are related to your speed related question. I mean, usually you have timing constraints like multi-cycle path properties or so that you can formally verify. So, I mean, this is related to that.
I think we need to think about these in terms of cycle performance rather than megahertz performance. The number of cycles it takes. So, for example, could you write a property that says that this result will not be available after 3 cycles, and then try and disprove that property? So you can see the result after 3 cycles. That type of thing, I think, is what Chris is talking about.
Okay.
If I remember correctly, with behavioral property synthesis, we did work on performance bugs. We were able to find the distance between events and show whether they are sufficient or not. But I have to remember the exact specific details of this use case. So I think we have done something like that in the past. I need to get back to you, Chris, on the details.
Yeah, I think I've seen people specify properties like this. This result will not be available in time, or will be available in time, or not available in time. And then if you can't come up with a counterexample, I can't quite remember the details, but I've done it before. So I think there's one more question online. I think it's a good last question because it's very future-looking. Can you predict when the formal tools will start doing system-level verification? So I think most of us engineers are producing systems rather than, I know there's a few IP companies here, but a lot of us make systems rather than IP. So, and those will start to involve software as well. And I think maybe what John was talking about, certainly it's system level type properties, which our keynote was speaking about at the beginning of the day.
So, talking about the past, right? When did we start to do system-level verification? Because I think, you can correct me, Sai, I think in 2009, JAG, one of the customers presented system-level reset verification with Jasper Gold, right? With about 1.5 million flops. Yes, so definitely there are specific activities like connectivity that everyone is doing at system level. Of course, if you want to go to full functional verification at system level, we're not there yet. We're not even often at subsystem level, SoC. So we are scaling, and this is our top priority. And I would hope to say that in 2 years, we should be at the SoC level and then scale up from there.
Okay, so, but SoC level, you have SoC level within your site, even if, and then beyond, you might be able to include software as well. Maybe.
There is, of course, some application which works on the sub-level, so like connectivity. But there is also application like secure check. They are working not only the module level, it's working on subsystem level because from there you can have more attacks and more paths. So even my experience is there is no, the design is actually who decides if you are, if your module check is okay or not. Sometimes we have what we call automated checks. This is sign-off checks, kind of linting, dynamic linting. And this is used by people on the block level. But as this is actually a good application, they try to use this on the SOC level, the subsystem level. And we have seen good results. So there is no rule to say don't try it. I was supporting some customer to do hand checking in this level and reset checking also, some kind of reset checking at sub level, and it was actually possible. So it is not what you have to do every day, but it depends on the SOC, it depends how you set up the tool, how you make some kind of complexity reduction. You can do form verification with SOCLAB.
So in Spyglass, for example, we're doing system level verification, and simply because our users they just give the full SOC, the full design constraints, and then they expect a push button flow. So we're doing this already. So for applications like a CDC, for example, you need to consider several domains, which is naturally on the system level.
Yeah.
That's a question how you deal with this.
I think the person asking the question was implying more than just SOC, but they said system. They were talking about software as well. But I understand your point that getting to SOC levels has been a big. That is a huge leap in capability already.
Dealing with software alone is a way other thing. Yeah. So this is even not well understood. There are some nice advances at Microsoft Research, for example, but this is still, I would say, in its infancy.
And same as the people. This is OneSpin again. Same as the people before me said, the key is complexity reduction. So if you black box cleverly, you can prove some things, and there is already. Connectivity checking is done at SOC level. And all this, but I'm not brave enough to put a number of years on when we're there at running system level checks.
2 years.
The whole functionality. Yeah, 2 years.
Now it's on film, right?
We look forward to 2018.
As it was pointed out earlier, it's a piece-based complete problem, and there is no free lunch, so there must be some black boxing, either automatic or manually.
Good question. So, follow on.
Hi. So I can think of a time when we could tape out just using simulations, but today we can't tape out without using emulation. Right? Emulation is an acceleration technology for simulation, and emulation also has other applications like software bring-up and other things. But under the hood, it's really an acceleration engine for simulation, right? So can we expect an acceleration box? Can we expect your sales guy coming around to us and saying, yeah, you got to buy this box, it's going to accelerate your formal proofs?
Just giving a business idea.
Yeah, actually.
And the answer, probably, the question is, are we expecting acceleration boxes for formal? And maybe. There's been some research about it, and the results are that it doesn't lend itself well to the level of parallelization you can get with a GPU or something like that. So at least to this point, it's not clear what the answer is. But maybe, we are looking for opportunities to accelerate formal and scale up, and wherever we can find opportunity, we will go there.
So I didn't necessarily mean GPU, like running some kind of software on the GPU hardware. I actually mean something like dedicated chips or a platform to accelerate the algorithms under the hood.
I think it's called a quantum computer.
Anyone? No. Okay. So, final question. Everyone's got a final question.
Actually, this is the first and last question, hopefully. It's a question to the 4 vendors, actually. If I have a connectivity flow where I do not have any spec, is there any possibility of any of the existing tool vendors where you can look into the HDL design and propose an connectivity pin list information to the users? Did you get the question?
Yes. So we
reverse engineer.
Yeah, it's the reverse engineering. It's not the reverse connectivity I'm talking about. It's the actually coming back with an Excel format or CSV format.
We have a prototype for this. We are working on this, and we have something which is coming soon in 1st of July in the next release, and you can try it.
Does it support all of the Verilog, HDL,
Yes,
VHDL,
yes.
and system Verilog, everything?
Yeah, everything.
Okay. Yeah, thank you.
It's a lot of area we're struggling actually.
Yeah.
We don't have this spec.
I'm sure you're not alone in not having the spec. So, okay. So, sounds like you've got a sale.
Thanks.
Okay, so just before we go, I just want to say some thank yous. Thank you to the panel. Everything. Okay, so thank you to our sponsors, and you can see them in front of us here. So, Cadence, Mentor, Synopsys, and OneSpin. Thank you to our speakers as well. So, John with the keynote, Ashish. Trying to look around to see. Alex has gone as well. But, okay, and but again, just a quick special thank you to Ashish as well. Who helps us put these together, although his name doesn't appear on there. So thank you very much to Ashish as well. And I guess we'll see you all next year. So thank you very much for coming. I hope you enjoy the day. And see you next. Thank you.